can now proceed with our next presenter, who is Dr. Haruna Isah. So Dr. Haruna Isah is a research associate and a team lead at the Canadian Institute for Cybersecurity at the University of New Brunswick. Before joining CIC, Dr. Isah was an IBM associate postdoctoral fellow at the Big Data Analytics and Management Laboratory of the School of Computing at Queen's University in Kingston, Ontario, Canada. Haruna has a PhD in computer science from the University of Bradford in United Kingdom with a thesis entitled Social Media Mining for Crime Intelligence. So Dr. Isah also has a Master of Science degree in Software Engineering from the University of Bradford and the Bachelor of Engineering degree in Electrical and Electronics Engineering from the University of Maiduguri in Nigeria. So his current research interests include IoT security and data protection, big data analytics, natural language processing, machine learning, and deep learning for cybersecurity. So Haruna, thank you very much for being with us today. We are all ready for you. The screen is yours.
Thank you very much, Farouk. Can you confirm that you can hear me?
Yes, I hear you very well.
Thank you very much. So let me share my screen. And while I'm doing that, I will join my colleague to also say thanks to the organizers for providing this platform for us to share some of the things that we are currently doing and also to interact with some of our colleagues. And so, as he mentioned, I'm a research associate and project lead here at the Canadian Institute for Cybersecurity in Canada. And I currently lead a project that looks into interpreting AI-based machine learning models. My discussion may not be around that area for today, but I will look into how AI-based models can be interpreted, especially in the criminal justice and financial sector. So my presentation today is outlined under these four headings. First of all, I will have a discussion about background. What is cybercrime? How is machine learning and artificial intelligence intervening? And then I will look into, we'll talk about ecosystem of interpretable AI and machine learning. And then we will look at real world use cases, including what the Canadian government is doing. And then we will draw some conclusions, including research and development opportunities. So let's get going with the background. So this picture is from Elvas, and I really like the way they put the definition of cybercrime. Any and all illegal activities that is being carried out using technology. And the technology can be the tool of cybercrime, or it can be the target of cybercrime. So technology can be attacked, or technology can be used to commit cybercrime. And there are so many activities. Some are directly the cybercrime, some are activities that lead to cybercrime. And these are the ones that either I'm currently working on, or I've worked in some of the projects that I had here. So these include identity theft and fraud, credit card theft, data leakage, sales of counterfeit drugs, phishing, and then there are so many other activities, including cyber terrorism, cyber laundering, cyber hacking, cyber stalking, sexually explicit content, and child pornography. Now, how is AI and machine learning intervening? So not just in crime, in the area of crime, artificial intelligence and machine learning is increasingly gaining importance and utility in so many sectors of the economy, including government, including industries. So for today, the focus of the discussion is going to be on criminal justice, payments, fraud, and insurance. And as a background or a motivation, previously I did some project on crime prediction, and the focus of that was to go a step ahead of the criminals by mining discussions on social media, by mining Google searches to see whether we'll be able to help agencies and regulatory bodies that are directly involved in anti-counterfeiting activities, the sales of counterfeit medications, to be able to allocate their resources widely. So how can we identify hotspots? How can we identify the names of organizations, of individuals or groups that are actually involved, like network that are involved in this thing? Because we know that an individual will not be able to carry out all these things. There are a network of organizations. And this involves risk scoring. So most of these cases, especially in criminal justice, crime prediction, you do some behavioral analytics on social network, and it involves humans, it involves people. And so there are a lot of techniques that are currently being used to automatically detect cybercrime or suspicious events that looks like cybercrime. And when I show my references later, you see that reference number 2, they really did a great job in summarizing research techniques, algorithms that are currently in use, starting from statistical method to rule-based, to classical machine learning, and then to deep learning, which is currently the state of the art in so many areas, for instance, natural language processing and vision. So they really did a great job. And also, there are some platforms, two platforms that I found very important or very relevant. The IBM's Auto AI, which was developed based on Apache Spark and some other open source technology. And then also the Fits AI. They also have an open source ML engine. And these engines are actually specific for fraud detection, for designing and developing solutions for fraud detection. I must emphasize that I'm not promoting these organizations or these tools, but I found them very, very interesting. So we talk about academic research, and then we talk about platforms that researchers and developers can use to develop fraud detection solutions. And also we talk about real world scenarios. So these are payment services. You have PayPal, you have Visa, and you have MasterCard. And these services have recently embarked on integrating machine learning into their systems for fraud detection at real time. So they sift through transactions such that they'll be able to, at real time, detect suspicious transactions, put them on hold, and then ensure that legitimate transactions are processed with no hiccups, with no delays. So these are some solutions that are benefiting from AI and machine learning. Also, the government is delving into using AI for productivity. Now, what is the issue? Is AI or machine learning model bias? A popular maybe controversy that if you Google the Compass software or the Compass algorithm is an artificial intelligence or automatic decision system that is being used in criminal justice to predict recidivism, which is a tendency of either convicted criminals to also commit another crime, and is currently being used in some cities or some states in the US. So it assists judges and people working in criminal justice to be able to predict future criminals. But the issue is that, so these researchers, the name of their publication is Machine Bias, that there's a software used across the country to predict future criminals, and it is biased against blacks. So what they analyze the software, and based on their analysis, they discover that those whom the software labeled as higher risks in committing future crimes, the proportion for African Americans who never commit the crimes is so high, almost 45%, while the proportion for the whites who didn't reoffend is just 24%. And the controversy is those that were labeled as lower risks, as you can see for the whites, 48% did reoffend, while only 28% of the African Americans were found to reoffend. And so this attracted a lot of attention. There were a lot of rebuttals, those against and those for. But the consequences is the most is the main issue here, because if you read through the publication, you read that there was one lady who was not formally charged, but on this software, she was rated, or she was scored as medium risk. And according to her, that stood, it acted like an obstacle in getting jobs or having access to credit facilities, because already she has that potential to commit future crime. And there was a ruling based on this software that, yes, I think the ruling was in support of using the software, but that there should be a kind of a warning message or regarding the limitation of the software. So yes, you can use to assist in criminal justice system, but you should put that, okay, this is the limitation of the software in such a way that you can have maybe a human that will come and maybe intervene. Now, that is not just an area. There are a lot of areas. Maybe in the next few years, we might begin to have driverless cars. But one of the challenges with driverless cars is that people with dark color, dark skin like me, they are finding the technology is finding it difficult to be able to recognize and detect. So now as a pedestrian, that means if I'm crossing the road and then there's a driverless car that is passing, then I stand the risk of being killed. So this is another area that requires explanation of understanding why technologies like this are behaving in such a way. And there are many other areas. For instance, you have the consumer lending discrimination against the Latinos and against African Americans as well. And then you also have gender bias in Amazon CV screening. This is an interesting one. Amazon developed a software that will be able to screen CVs, and they later discovered, so thankfully Amazon, they have interpretability. So they later discovered that females and males with the same CV, the software is dropping the females and then keep picking the males. So the software has gender bias in it, and then they were able to tackle it. Also, there's racial bias in health decision algorithms, where you will see that the algorithm was designed with features that do not benefit some people or communities that are disadvantaged. So the big question now is, are these models inherently discriminatory by design to discriminate against gender or race? And my answer is no, because I don't think the developers had in mind that let's develop this thing in order to target this particular group or particular race. So this could be something that maybe during the design, there were certain considerations that were not made, or maybe the algorithm is putting a lot of weight on certain features or data components that is actually affecting some sections of the community. So, and this is what actually brought about the need for explainable AI and model interpretability. So let's see what explainable AI. So before the definition, it's actually an active area of research as well as practical applications in the industry. And then there are a lot of stakeholders. I initially mentioned the Canadian government. I will also mention it towards the end of the discussion, the talk. So they're interested in the use of responsible artificial intelligence and machine learning in their services. And then you also have developers who want to understand the important features to improve in a model. So interpretable, explainable AI has a lot of stakeholders and a lot of usage. You also have researchers who are interested in identifying algorithms that are capable of interpreting many models, not just a specific model. And then you also have application engineers who are monitoring deployed machine learning and AI systems so that they'll be able to have a better explanations to end users as to what and why of the applications, and also for ease of troubleshooting. So there's two major categories of AI and machine learning algorithms. You have the white box and then you have the black box. Now the white box are those that are easy to understand, easy to explain by experts in the domain, while the black box are those that are hardly understood even by domain experts, and they are extremely hard to explain. I know majority would think of deep learning models falling here, and models such as linear regression, maybe decision trees, also in this category. And explainable AI, there are three basic principles underlying this, the concept. One is transparency, then you have interpretability, and then you have explainability. And explainability is trying to open the black box, because black box, as I said, in some applications are very accurate in terms of performance. So explainability tries to open the black box such that while you are enjoying the performance, you also have the interpretability feature. So you understand the inner workings of the machine learning models. And the interesting part is that its explainability is becoming part of laws now. So for instance, the General Data Protection Regulation, which is an EU rule, I think it came up in 2016. It empowers data subjects. So someone like me, someone like you, whose data has been captured by any organization, now you have the right to meaningful information in understanding what logic is involved and what are the consequences of automated decisions in using your data. There are other articles also that entitle us to an explanation of automated decisions and also gave us the right to challenge any decision. I could apply for, I remember previously there was a weekend, one weekend I made an application for an insurance, car insurance, and then the application bounced back. But during the week I called my application, I did application online. They said, no, you shouldn't have done it online. You should have called us. So, and then we discussed, and then I got approval. So I should have asked, so what is it in that software that actually rejected my application, that if I call, the application can be processed? And not just GDPR, which covers the European Union, we are also beginning to see so many other laws, like in Canada, we have PIPEDA, in California, we have the, I think is it California Act, data usage. So there are so many laws that are coming up that empowers the data subject, and also is putting pressure on companies and organizations to obey such laws. Now, machine learning interpretability is the ability to determine the cause and effect from a machine learning model. It's a critical prerequisite for explainability. And so this sums up what machine learning interpretability means. You have, so let me use a laser, see whether you'll be able to see. So you have the world, which could be transaction from financial institutions, it could be network traffic data, and then you capture the data, and then you learn. So because of their popularity, your model could be a black box model from deep learning, and then you want to extract the weights or features from the model using interpretability methods, such as to inform humans who will be able to, in some cases, intervene where there are suspicion. So there are so many objectives of interpretability. First, let's see why the demand for interpretability. The major issue is mismatch between formal objective of learning and real-world application. So you develop your model in a controlled setting, the model behaves very well, you get 100% or 99% accuracy, but once deployed, you begin to discover that the model is performing very poorly. So can you trust the model? Can you have confidence in the system prediction? Is the model wrong when humans are accurate? So nobody would want to use a model in a production, especially in critical areas where there are questions, or that common sense should be able to decide that, okay, this is how it should be, and then you have a model that is giving you. So when a model is not trusted, then it's hardly used. And then what about unobserved causes? For instance, you design a model that is disadvantaged to some communities without your knowledge. So interpretability will be able to help maybe in looking into causality. And a major one, which I just talked about, is generalization. How is the model able to adapt properly to new and previously unseen data? And then also information. So interpretability is able to give you extra information at some point, especially when you are dealing with unknown data, or especially in the case of network analytics. You are dealing with new attacks that you've never seen before. When you use interpretable machine learning, you'll be able to gain new information that you can add to optimize your system. And then most importantly, in the case of criminal justice, you talk about fair and ethical decision-making. Interpretable machine learning is aimed at preventing discriminatory outcomes. Now, there are two major properties of machine learning. You have transparency, and then you have post hoc interpretations. And transparency looks into three major issues. Simulatability. Can humans walk through the model steps from the beginning, end to end, to understand that this is how the model works? Then decomposability. Is the model interpretable at every step? Then you talk about the algorithm. Does the model algorithm confer any guarantees? In terms of interpretation, you look into how do you relate the information. Is it in form of verbal explanation? Can the model explain its decision in natural language after the fact? Or are you using visualization? Can the model identify visually what is or what was important to its decision making? And there are so many methods. There are so many methods that are used to interpret black box models. But even before the black box models, there are models that inherently are interpretable. So you look at models like linear regression, logistic regression, decision tree. I think in one of our projects, the question came in, if there are models that are already inherently interpretable, then why do we have to go and use models that are complex and now trying to get to interpret or explain the model? So it depends on the situation you are dealing with. When you are dealing with simple problems that you'll be able to model with algorithms such as linear regression or decision tree, fine. You have feature importance, you have things like weight plot, you have effect plot and tree decomposition embedded already in these ones. Otherwise, you can use models that separate the explanation from the model. There are so many algorithms. Popular ones are the local interpretable model agnostic explanations, which aims to interpret just an individual prediction. That is why it's called local. And then you have the sharply additive explanation, popularly called SHARP. And then you have example-based explanations, such as counterfactual explanations, whereby you try to perturb the input to see how does that affect the output. And there are a lot, and there are even more that are specific to the models. So for instance, this book by Molnar Christoph covers a lot about interpretable machine learning. So for more details, if you're interested in more information about this method, this is a discussion for a day on its own. The book also provided some taxonomy of machine learning interpretable methods, interpretability methods. And you can either classify the method as intrinsic, as we discussed, those that they already embed interpretability in them, or methods that it's after the prediction that you use maybe another mechanism to interpret it. And then there's categorization based on the result of the interpretation method. So are you interested in just basic statistic as a form of interpretation or visualization or weights, for instance, in neural networks? Or are you interested in model-specific methods? So those ones are specifically designed for a particular model, or a model-agnostic method. So those ones are independent of the model, and this is the direction of research. Researchers are interested in developing models that can interpret all kinds of machine learning algorithms. And then whether the models are local or global, in the sense that local is just focused on independent interpretation, independent prediction interpretation, while the global looks into end-to-end. And then there are so many libraries. So these libraries are unified frameworks that have been developed mostly from research institutions. And they ship most of these algorithms. For instance, you have LIME, which is able to explain single predictions, a prediction in black box models with more than 2 classes. And then you have the SHARP library, which follows a game theoretic approach and can assign feature importance value for a particular prediction. And then you have the SCADA, which is able to provide both local and global interpretation. And then there's this one, I like this name. It says explain like I'm 5. So this is able to inspect the model parameters to figure out how the model works globally, as well as to inspect individual predictions, and then figure out why the model makes its decision. Then we have CAPTUM, which is comprehension in Latin, and is tailored towards developers that are using the PyTorch framework for their development. So there are so many other libraries that are useful for interpreting black box models. So this is a simple example of how interpretability works. So in this case, you may have your data, and then you can choose your algorithm. It can be a gradient boosting algorithm, and then you do some classification. So after the classification, you will be able to see your results, the truth table. After obtaining the result, then you can now decide to choose any of so the ELI file is there, sharp is there. You can choose any of these, and then you'll be able to have a global interpretation. What are the most important features in this model, as well as a local interpretation. You'll be able to filter each prediction and then see the red part might be, these are the features that actually contributed in the prediction, while the blue parts are the features that actually did not contribute or are even making the model to have a poor performance. So this is a simple preview of how interpretability looks like. Now, let's quickly run through a use case. Intrusion detection and payment fraud. These are two critical areas, and both areas, they mine data, or they do behavioral analysis, so they affect humans directly in some way or the other. So the problem is that you have attackers that are exploring newer patterns of attack, to attack cyber infrastructure and commit financial crime. And the research community were able to develop intrusion detection systems and fraud detection models for solving this issue. And the deep learning-based models recently, because of their high performance in terms of detection, are being used, but their complexity, making them not interpretable, is an issue. Apart from the ethical aspects and the transparency aspects, there are also many state-of-the-art, as I said, models that are suboptimal in production. And so there's need to evaluate the model features and then explain their influence. And this is where interpretable AI and machine learning help. So going back to that interpretability workflow, so this is a typical use case where you have a network traffic that is being generated by benign users as well as an attacker mix up in the same traffic, and then you capture the data, and then you develop intrusion detection models that will help you to detect and classify the traffic into different kinds of attacks. It could be port sweep, password gaze, teardrop. And then after that, the interest is to extract, to be able to understand why was a particular traffic flagged as gaze password, why was a particular traffic flagged as a teardrop. So there are so many methods we can use for that. You have the sharp. These are the libraries that I've discussed previously. And the interpretation could be in a form that the interpretable machine learning is telling you that because the number of hot indicators is 1, and then the source byte is 125, this qualifies this traffic to be a gaze password. And then now the analyst now has a better visibility to either approve that yes, this is should be flagged, or to say no, this might be an anomaly that may happen. It might be an outlier. So, and I mentioned that interpretable machine learning can lead to additional information. So situation whereby the analyst or the system is able to discover new pattern of unknown attack, then this now forms a new signal or a new rule that can be added into the model to improve its performance. Again, the model can also be enhanced in such a way that you embed natural language processing API and to form a decision support system such that even someone who doesn't have knowledge of network traffic will be able to understand the natural language that's, okay, these are the issues, and then be able to evaluate whether to approve or not approve. So the explanations based on this interpretability library include understanding relationship between targets and input features. So that one is targeted at data scientists who are interested in understanding this relationship. And it could be just explanation from the data, which is targeted at data analysts. They want to discover or to find out what is actually the difference or the similarity between the data that has been used for the training and the data that is in real life. And then the end users are also important stakeholders who might want to understand which feature in the input instance are contributing to the model's final decision, and in learning what can be tweaked in order for the model to maybe, for instance, you apply for a loan and then the loan was rejected. So an end user would be interested in understanding if the decision is based on this model, how can the model be tweaked? What are the features? Probably you need to improve your income. So these are some of the advantages or objectives of interpretability. And then the other use case is in fraud detection, where you have credit card transactions, legitimate ones, and then maybe transactions from stolen credit cards. And then you capture all these. And then the interest is to develop a credit risk or fraud prediction model to either approve, reject, or put on hold a credit transaction. And the two use cases I talked about are actually use cases that requires real-time intervention. So you don't want to allow suspicious transaction from a stolen credit card to succeed. And so you also don't want to put a legitimate transaction on hold for a very long time, because that will not be convenient to a customer who is not is not an attacker, or who is not a bad agent. So techniques for interpretability include relevance analysis, sensitivity analysis, and because in this research a neural network was used, then we also have neural activity analysis. And this, in the same vein, the goal is to inform the analyst as to why a particular transaction was rejected or put on hold. And the explanation could be because the individual performing that transaction has a high risk score, probably due to the person's order history, the person's account age. Probably the account was just created that day, and then there were multiple transactions. So in such situations, the transaction may be put on hold, or maybe some missing information. I remember traveling to Nigeria and trying to come back. I was purchasing my plane ticket and my transaction was denied. I tried several times, my transaction was denied. I had to call the bank here in Canada that why was my transaction declined? And I was told the IP address I'm using is actually strange, that I've not used that IP for some time, but now that they know it's me, they are going to open the security feature for an hour. So I had 1 hour to proceed with my transaction, and then my account will be put back on similar security again. So this also informs the analyst as to either review, approve, or continue to put that transaction on hold until they are very clear that yes, this transaction is suspicious. So these are two interesting use cases. And the same vein, the interpretation using relevant analysis was to understand how much of the output is directly due to the given input variable, and how much does the output change due to a small change in the input variable, as well as to understand which neural paths are most activated by a given input variable, and also to understand whether there are biases in the data or the model. So this is one of the examples or one of the applications of interpretability. This is a research by Microsoft, and they are showing a decision mechanism or interpretable explanation to someone whose loan application was rejected. So you have your original inputs, and then an automated decision was made, and then it's end up being a rejection. So they call it counterfactual examples, and then they show the clients, okay, these are the things you can do in order to gain approval. So you could increase your income by $10,000, or you can increase it by 5,000 and have 1 year of credit history. So these are some of the advantages or applications of interpretation of explainable machine learning. And the Canadian government is using artificial intelligence to enhance its programs and services, and it's working hard to make sure that whatever it's doing is governed by clear values, ethics, and laws. So, and the guiding principle is to be transparent, to understand and measure the impact of using artificial intelligence, as well as to provide meaningful explanations about AI decision-making, and to be as open as possible. They also want to provide sufficient training to all stakeholders. And in doing so, they came up with algorithmic impact assessments, AIA. Is a kind of a mandatory risk assessment tool with a lot of questionnaires, I think more than 70 questionnaires, and is aimed at rooting bias and inequality in AI. So if you're going for procurement or you have a project, you have to go through these questionnaires, and then you have in scoring, automated decision scoring, that will be able to either allow you to proceed to the design phase. So that ensures that whatever you are working or you are producing is going to be governed by clear values, by ethics, and also by laws. And then there are also specific instructions. So this is a recent initiative. It's called Directive on Automated Decision Making, whereby federal departments in the government of Canada that are using AI are provided in such a way that they will guide all their projects or all their department and services that are using AI to ensure that whatever they are doing is governed by clear values, ethics, and laws. Yeah, so in summary, there are many machine learning AI-powered systems currently in use in critical areas like the criminal justice system and fraud prevention, but there's a major setback. Interpretability is an issue. People need transparency. People want to trust the system that, yes, this system is doing what we expect it to do. And so is an interesting area of research, making AI models inherently interpretable, or designing interpretable methods in such a way that models that are black box in nature will be able to be interpreted. And then another area is improving models that are in real life to make sure that their performance in control environment is the same in a deployment environment. And as I said, the directive on automated decision, if you're a Canadian researcher, it's going to have an automatic review process plan every 6 months. And so we encourage more cybersecurity researchers and practitioners to get involved. There's a Google Doc online that they welcome feedback so that it will shape their own their next move. Thank you so much. So these are some of the references I consulted. If you want to take a screenshot of it, you're interested in the slides, get in touch. Yeah, so you can get in touch with me via this email or to CIC directly. And thank you so much. Look forward to your questions if there's any.
Thank you very much. Thank you very much, Haruna, for this presentation. So we have only 5 minutes left. We have one question. I will read it for you. It says, some AI systems make several thousands of decisions per second, making it difficult for human intervention. Can the analyst in the use case be replaced with an AI system?
Yeah, that's an interesting one. So for instance, in the financial sector, you have millions of transactions being processed, and then you wouldn't want to affect legitimate transactions being processed. And you are also interested in trying to stop fraudulent transactions from taking place. So it's possible that the human intervention will be reduced, not really fully taking it over. So after the first maybe interpretation level, you also have another interpretation level whereby is system that is sending the solution to another system to make a decision which will be faster, but it has maybe another second level of features in it that the first level is not able to perform, so that it will reduce the amount of job that humans can do. So it reduces the amount of intervention by the humans.